How's everybody doing today? Is it nervous in this room, or is it just me? I figured that would work. So I'm Brian. I'm a production engineer at Facebook. I work on the monitoring system. The monitoring team at Facebook is a little different than monitoring teams at other companies. Rather than like owning the monitoring like for the company, what we do is we build the tools and systems that teams can use to like debug their systems when things go wrong and be notified before that happens. This talk is sort of the culmination of like a variety of experiences over a period of years. It has sort of like a narrative that threads through it about like minimizing the amount of time that you have to spend paying attention to your system. And my hope is that you can walk away from this with sort of a more rigorous way of thinking about how you design monitoring for a service, rather than what, I mean, honestly, we're all pretty guilty of this. Like sometimes you just don't know what you're doing, so you just throw metrics at the problem so you can like figure out what's going on. I've got a few high-level things that I want to talk about. Like the value of measuring things specifically, using high-level alarms as opposed to alarms that target specific conditions, and then recontextualizing the way that you think about your dashboard. So let's get started with some of the things that kind of led me to these conclusions. The first of these is what I call high cardinality alarms. These are actually pretty straightforward. This is any alarm where if you've got 100 machines, you can get 100 notifications for a given problem. And they're bad for one reason, which is that they prevent you from seeing the forest for the trees. The next one is what I call reactive alarms, and these ones require a little bit more explanation. They don't happen instantaneously. Reactive alarms happen over a period of months or years, and you only notice that you've been doing this when it's already too late. The way they happen is that, let's say you're running your service, everything's fine, and one day you have an incident. You root cause your incident, you figure out what the specific thing was, you've also mitigated it, the problem's solved, and you say, I don't want this to happen again, I want to learn from my mistakes, so you build an alarm to detect on the thing that caused this problem. And then you do this again, and again, and again, and again, and all the while, at each step, you're doing what you think is the best thing for your service, and the best thing for the company. Except that 6 months down the line, a year down the line, 2 years down the line, what you find is you've got alarms that fire spuriously. They don't have any real relevance to the system. You sometimes don't even know what they mean because they were created by people who have left the team or even the company. Older on-calls trading newer on-calls say, oh yeah, that alarm, it just happens sometimes, you can ignore it unless this other thing's going on. Yeah, we've all been there, right? And basically, they seem like a good idea, and we'll get into why they aren't in a second. The final thing is what I call tool fatigue. How many people suffer from having too many tools? Yeah. I'm about to blow your mind, maybe, by telling you that you have more tools than you think you have. Tool fatigue is an on-call wiki with one-liners. An on-call wiki with one-liners is actually a whole crapload of tools with a poor interface and poorly defined purpose. These are, when you start to think about them this way, what you realize is that one-liners in an on-call wiki is actually the worst kind of tool you could possibly have. You run them by copying and pasting the source code of the tool, and you give them arguments by changing that source. And these cause a problem for you because you spend more of your time trying to find the right tool than actually solving the problem. The thing that all of these have in common is that they all seem like good ideas, but they're not. At each step, you're trying to do the right thing. You're making the best decision you can be making, right? and they seem obvious in the moment. But by the same token, putting a little forethought and using a few key practices can lead to dramatically better monitoring. So next up, we're going to talk about what I mean by measuring things specifically. Before I worked on the monitoring team, I worked on Facebook's distributed message bus Scribe. And the Scribe has a lot of interesting properties, and you can come ask me about them after the talk if you like. But the thing that I want to focus on here is the read API. The read API for Scribe is built like a traditional Unix utility. In order to use ptail, it's the blue box over there, you fork and then exec, and you read it standard out. The arguments that you give it are the parameters to control where in the stream that you want to read from and which stream you want to read from, and then you just consume the messages over a pipe. ptail itself had plenty of metrics for debugging its internal state. It would tell you pretty much anything you wanted to know about it, but it didn't have an answer to one key question, which is that people actually, what the question they really wanted to answer about their applications was, is my application too slow? And the way we used to debug this, and we'd have to help teams do this because it wasn't always clear, it wasn't always immediately obvious. And I'm sorry, I know these lines are a little hard to see back there, so I'll help kind of guide you through it visually. What you'd have to do to debug this problem is you'd pull up a chart with a few lines on it. One of them was called backlog, which was a measure of how far behind ptail was in the stream relative to real time. The other one was write rate, which was how fast ptail was writing to standard out. And between these two metrics, it turns out that you could actually, with a bit of time, patience, effort, and usually having to also dig into the logs, figure out whether or not an application was too slow. This took a lot of our time, maybe a few hours per week helping customers debug this problem. So after a while, we got tired of it, and it required a little bit of insight. But we realized what we actually wanted to measure was, is ptail just waiting to write to standard out? Because the way a pipe works is that the writer process will block if the buffer in kernel fills up, right? So we just added a metric. It was 1 when ptail was waiting to write, and 0 otherwise. To debug whether or not an application was too slow, you pulled up this one line on this one chart, and you examined the density. Who here can see where maybe the application was slowing down? Kind of surprisingly obvious, isn't it? The moral of this story here is that don't force yourself to do more work than necessary. Don't spend 15 minutes interpreting a chart if you can spend 3 seconds interpreting a chart by having a better metric. Not only does this waste your time, but it makes it harder to build automation. The state of the art of time series analysis is still in its infancy. There's not a lot of exciting, there's a lot of exciting work going on, but none of it's really ready to be used in production. So if you can simplify the analysis down to a single time series, it'll make it easier to build automation. Who here saw Romaine's talk on Dapper and cluster automation? Yeah, this ties directly into that. Later, we developed a slightly better metric that was even nicer to examine like this, but the idea remained the same. After a while, we still had this problem on Scribe. We solved one big problem that was wasting our time. But we realized that we had another problem. It had a lot of these high cardinality alarms, and we came up with this idea of signal actionability and relevancy. Before I get any further, I want to clarify. There's really 2 kinds of alarms, and I'm talking about the latter kind here. The first kind is alarms that are meant to be processed by machines. It is perfectly fine to have 1,000 alarms for my disk is full as long as a human is not involved in them. Right? I don't want to get 1,000 emails for 1,000 problems. The second kind of alarm is the ones where it does require a human's attention. The kind where it generates a notification, the kind where it wakes you up in the middle of the night. And this is the kind of alarm that I'm talking about in this talk. Also, I just want to point out, actionability is a word. I looked it up. A lot of my reviewers were like, is that even a word? So yes, it is. SAR is for measuring what reaches humans. I'll quickly kind of go over these, and then I'm going to delve into the last two. Signal is really just a proxy for the underlying metric, right? If you measure things specifically, the signal of your alarm will be pretty easy to gauge. But in general, you're answering the question, when you get an alarm, you ask yourself, is this a false positive? If the answer is yes, then your alarm doesn't have enough signal. Actionability is the answer to the question, when I get this alarm, can I do something about it right this second? And I don't mean act the alarm and go back to sleep. I mean wake up, pull out my laptop, and actually, do I have to debug something? And relevancy is, the answer to the question is, when I get this alarm, did another one fire that more or less tells me the same thing, or do they tell me something overlapping? If the answer to that is yes, you need to delete one of those alarms. Actionability is the #1 thing that you can improve when you're thinking about your notifications. Notifications that do not require human attention degrade everything else. Scribe could actually completely ignore our service, despite the fact that in the time that I was working on it, it grew literally 10x in size over just a couple of years. But we could ignore it because we focused on this so religiously. We eliminated 97% of the alarms that we got just by using this approach. The next thing we did was we improved relevance. We took away all of the alarms that told us overlapping things, and we wound up with basically one alarm per layer of our stack. A way that you can think of relevancy is it's a little bit like entropy. The fewer alarms you have, the more each individual alarm tells you when they fire. This is good. You want to maximize that. When you improve relevancy, you improve aggregate actionability. In an extreme case, you might actually have only one alarm for your entire system that literally is, it's broken, start debugging now. This is actually the final real slide of my talk. I purposely kept it short and sweet and did a lot of, was very prescriptive because I wanted to open it up to the floor as quickly as possible so we could actually have a discussion about this. The last thing I want to talk about is your dashboard is your debugger. It's not a passive tool, and this was the most important thing that I figured out. What you're seeing here is, I'll give you a little description, a stack trace from an internal system that I blurred out for legal reasons, and then a dashboard called, it's an internal dashboard we built on top of Cubism. Is everybody familiar with Cubism? Okay, so since most of you aren't familiar with Cubism, I'll go ahead and describe it. Cubism is a graphing technique that exploits the way humans process information visually. It transforms basically vertical height onto a chart into density, and humans are really great at understanding density. So who here could take a guess at where problems might be? I know in the back it might be a little difficult. The graph isn't super huge. This one? Yeah, look at this. So basically what happens is you say, this is the minimum and maximum bound for my metric for like what the good range is. And then every time the metric is above that, it rolls over repeatedly and darkens the graph so that you can visualize, what is that, like 20 metrics in one stack. And you can look at them and analyze them to instantly understand. Cubism is open source, by the way. Facebook didn't build it. We're just benefiting from it. When you build a dashboard and you start thinking about it like a debugger, you realize that the way that we've traditionally thought of dashboards as a thing that you kind of like go to understand what's going on is wrong. You wouldn't develop software without the ability to print F, and you wouldn't develop software without the ability to set a breakpoint and examine the local scope. A dashboard is actually a continuously attached debugger. It is measuring the internal state of your system all the time, and you should think of it like that. Your dashboard should allow you to drill down, like go from a high level, what I call total view, go, oh, my total view says there's a problem in this layer, drill down. Now I have all of the charts for that layer. I see, oh, it's localized to this subcomponent, drill down. And and then I understand what the problem is, and I've debugged it in 2 steps. I've seen a lot of dashboards where the approach taken to the dashboard, and I'm certainly guilty of this myself, is you just throw all of your metrics onto a web page, and you go, there, I got it. I can now find information. You have to spend some time and actually think about what the information means and how you want to organize it. Like, putting all of your metrics unorganized into a single page or even a couple of pages is tantamount to saying, well, I've got a dictionary in my code, but what I really want to do is stick it in a list so that every time I want to find something, I have to do a full scan. That's it. Questions? Also, I gave you a link to Cubism if you want to go check it out. It's pretty awesome.
Thank you for the presentation. I'm wondering if you've done any analysis on your signal-to-noise ratio, the SNR, between your metrics and how many of them are actually false positives or false negatives.
Yeah, so that actually is a good practice to have. On Scribe, it turned out that the signal-to-noise ratio when we started out was so bad that we didn't actually need to do an analysis. It was just oh, that's garbage, throw it away. Oh, that's garbage, throw it away, throw it away, throw it away, throw it away, right? But absolutely, there are other teams that do pretty extensive signal-to-noise analysis. They meticulously track things in on-call reports. Next. Did that answer your question, by the way? Perfect.
How do you determine what's important and what's unimportant noise, and how does that change as systems get bigger or Moore's law takes in more effect or so on and so forth?
Yeah. The way we do it, the way every team that I've worked on is been a little bit different. There's one no tried and true method. When we were rigorously cutting things down, especially when we got to the relevancy phase of the compaction of our alarms, what we started doing was asking ourselves, is there a better way we could be measuring this, right? That's really just the singular question. You just keep asking yourself that question until the answer becomes, I don't know, maybe no, right? It kind of it's yes, 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 maybe no, I don't know. In general, what we found is that a really good approach to this is that when you have an incident, and let's say maybe even only one alarm fires, right? And maybe that's actually good. You had one alarm that fired. Once you've resolved it and you've root caused it and you kind of understand what happens, go back over all of the metrics, all of them. It could be a lot. Find the metric that best predicts it, and make sure that that metric is the one that you can use. Does that help?
Yes, and I have sort of a secondary question now that you. So when you're doing these, when you're grabbing these metrics, are you grabbing a single instance point, or are you doing a multi-step test? Are you just pinging the homepage, or are you going I'm going to go to the homepage and then to my Facebook profile and then to my friends list and noting where the biggest delta in time change is, or something to that extent?
Yes.
Both of them, yeah.
Yeah, you want to take take the approach that basically whenever I work with a team, a question that frequently comes up is somebody will eventually say, hey, I've noticed that if we track this, we can answer this question. They say, should we track this? The answer to that question is always yes, unless it will impact the performance of the application. It's never bad to have too many metrics. More metrics is always better. It's basically, as long as you can organize them and choose the ones that give you the most signal for the problems you care about. When I said use high-level alarms, what I really mean is that depending on how you want to view a funnel, you either want to measure at the top of the funnel or the bottom of the funnel, right? Measure at the edges between systems, because that's where you're going to catch the most problems, right? So, for instance, one of the systems I work on as part of the monitoring team is this data visualization platform called Scuba. Scuba loads data in over Scribe, and then product analysts, engineers, like you name it, they use this visualization framework to understand like the behavior of whatever they're working on. It actually makes sense for us to set up alarms on behavior changes in like our top 5 data sets, because that is going to predict problems anywhere else down the pipeline in the production of those metrics. Thanks.
For your SAR, with determining what you're going to alert on, do you have some sort of like a rubric, or you're quantifying that, or is it kind of a subjective thing where you just say, should we be alarming on this? Let's use these 3 kind of semi-subjective standards to determine that.
Again, the answer is sort of like both. Like, it's not possible for me, I think, to say, like, come up here and say that there's like one true way that you should be thinking about this. Just that, like, becoming objective and having some set of criteria to think about this problem is much better than just sort of casting about in the darkness, right? Like, there's methodologies you can use to select like how to measure things. There's like Brendan Gregg's like use method, right? This is sort of complementary. This is like another. It is a thing that sits on top of that to say, what do I want to care about? Like once I've found metrics that are important to me. There's one team that I work with that does actually like. They try to like numerically quantify the SAR value. I mean, they don't call it this exactly, but they try to numerically quantify this. I've found that at least until I get a better understanding of it, like doing this subjectively works much better for me. Like the way I feel about an alarm pretty accurately like approximates its SAR.
Thank you.
Yeah. You okay?
Yeah, I'm fine.
Fantastic.
Sorry, only my pride. So when you talked about actionability and relevance, sometimes those are contextual depending on who's receiving the alarm or the alert. Can you talk a little bit about how what approaches that you're aware of to differentiate relevance to whom?
Oh, that's a great question. So I actually haven't dealt with. I've pretty specifically tried to avoid like dealing with sort of like shared ownership of an alarm. One of the things that like is interesting about Facebook's monitoring system is that like if one team collects a metric, any other team can like subscribe, like can make an alarm for that metric for themselves. So let's say that the monitoring system depends on some sort of directory service being up to date. And the directory service publishes a metric for like how far behind it is in updates or something like that, right? The monitoring team can say, wow, this is a really great metric for us because when this thing is out of date, the monitoring system doesn't work for whatever reason. This is just an example, right? We can create what we call a detector and then notify on the result of that detector independently of the directory service team. I'm trying to think if there are like examples of teams trying to do shared ownership. I think the relevancy question comes down to sort of like it basically comes down to a business decision, right? If you're producing like an API for an internal customer to consume and you've got like maybe a few big customers, it might make sense to set up alarms that maybe are slightly less relevant to you, but you're in a better position to understand like how to interpret the metrics, so that you can kind of like maintain that alarm on the behalf of the customer. It's definitely a business decision. Does that answer your question? Fantastic.
For the reactive alarms,
Yeah.
right? So there's a lot of people out there making what kind of process do you use to kind of herd them to be more oriented?
So the approach that I took on the Scribe team was kind of like one of like global consensus, right? Like I got the team on board with this idea. Apparently this is the most exciting thing I've said. Yeah. On other teams, it's sort of a continual process of education. Like after an incident, somebody will propose this and I'll say, hey, like that's a great idea, but like how can we make this more general? Like kind of just coming back to the question of like, this is like we want to detect this situation. Let's look at why we didn't detect this situation with our existing set of alarms and see if we can like fold this condition into another alarm. Because the understanding here is that like your alarm really, it should tell you like what layer of your stack or what general area you want to look in. Every attempt I've seen to try to use alarms to like tell you what the specific problem is so that you can then go fix it kind of winds up feeling like busy work, right? Like you either get a lot of them or you get ones that are like, run this command to fix this problem, and it's like, well, why couldn't it just do that for me? At Facebook, we have a system called FBAR that does a lot of this for us. But you can do this externally too. Like Nagios has event handlers, and a lot of the newer systems also have that. Yeah, it's a tough question. It is a people problem. And so like there's no one size fits all. I'm happy to talk about like any of this. You can come find me after we're done here. I don't know how much more time we have. We're done? Yeah, we're done. Fantastic. Thank you, everyone.